Hello dear students, welcome to the second C2208 Polymer course lecture. Last time I highlighted the importance of polymers in almost all research, applications and domains. And as I said that polymers are macromolecular chains composed of repeating monomer units connected together by covalent bonds. Here I want to precise that I talk about monomer when I have the monomer alone. Once the double bond is broken and this monomer is introduced in the polymer chain and connected to other monomers by covalent bonds, here it's becoming monomer unit or repetitive unit. So this is the difference between monomer and repetitive unit or monomer unit. Monomer once it's alone and it's named repetitive unit or monomer unit once it's introduced in the polymer chain. And the number n here, it's the number of this repetitive unit in the polymer chain. Before 1920, it was very difficult for scientists to believe in the existence of molecules having high molecular weight, higher than a few thousand, and they attributed the existence of high molecular weights to aggregations of small molecules. But the coming of Staudinger and his studies of natural compounds such as rubber and cellulose changed this limiting view, and Staudinger proposed the existence of macromolecules with high molecular weight and composed than more of 10,000 atoms. Also, he proposed a polymeric structure for rubber, natural rubber, based on repeating isoprene unit. So here we have the isoprene monomer, and here it's the natural rubber polymer composed of many repetitive units of isoprene. As each civilization is named after the material discovered and used, and as we are since the Second World War surrounded by polymers, the civilization age is named Polymer age till now, and I think it will continue to be for long time. The development of polymer history passed through many important stations which marked his history. We'll pass or talk about these different stations during this course. As I mentioned or I said last time, polymers are everywhere around you. Thus, 1,000 varieties of polymers exist nowadays, and others will be produced in the future. These polymers are not all the same and do not have all the same properties. Also, they are not all destined to just one application. Thus, this variety or large variety of polymers should be classified into groups. Why? What's the importance of such groupings? In fact, such groupings are very useful because they facilitate the discussion of polymer properties. But when scientists decided to classify polymers, it was not so easy, because the way they classify polymers is based on their experience. For example, an organic chemist is more interested in the detailed arrangement of atoms in the chain, but structural engineer is much more interested on the physical properties of this material, on each polymer material. So there's no uniform system to classify polymers. Hereafter, I will present classification of polymers based on different parameters. For example, classification based on source of polymers, on macromolecular classifications, classification based on architecture, molecular forces, the kind of monomers present in the polymer chain, on the different mode of polymerizations, and also classification into commodities and specialties. If we start with the source classifications, according to their sources, polymer could be divided into three categories. We have the natural, the synthetic, and the semi-synthetic polymers. First of all, the natural polymers occur in nature, and they have existed since life began. These natural polymers could be extracted, and they are very essential for life because they play a critical role in all forms of life. As they are natural, so they are from animal or vegetable sources. To this category belong polysaccharides and the polypeptides. The polysaccharides, they are based on glucose as repetitive units. And we have, for example, the starch, which is a long chain of glucose as repetitive units. We have also the cellulose, which is the most common organic material on earth. Also, cellulose is a primary constituent of wood and paper. Also, cotton is a cellulose polymer, which is formed from long strands of cellulose chains connected together with hydrogen bonds. And this cotton, for example, is used for many applications such as clothes. In parallel to cellulose, we have the chitin, which is amino sugar polymer. This kind of polymer is found in crustaceans, and they are similar to cellulose. The just one difference between chitin and cellulose is the existence of some amide groups pendant instead of some hydroxyl groups. So in plus to polysaccharides, we have also the polypeptides, which are proteins polymers, so based on amino acids as repetitive units. To this family of natural polymers belong silk, hair, which are protein polymers. The hair contain high level of cysteine as amino acids. Also, we have the wool, which is also protein polymer composed of around 17 types of amino acids, including also the cysteine, which is a specific amino acids containing sulfur bridges. And plus to these polymers, we have DNA as protein polymers, RNA, hemoglobin, collagen. Our muscles are proteins polymers. Our body fat is also is natural polymer. We have the natural rubber as natural polymer, etc. In parallel to natural polymer, we have the synthetic polymers. These synthetic polymers are derived from petroleum oil, and they are only the results of human creation. Means they are obtained by monomer polymerizations. Almost the majority of polymers around us are synthetic polymers. The third category of source classifications are the semi-synthetic polymers or artificial polymers. In fact, these semi-synthetic polymers are obtained by chemical modifications of natural polymers. Why we have to make some chemical modifications? What are the benefits of such modifications? In fact, sometimes we may have to make chemical modification for natural polymers either to improve their properties or to transform some of their properties. Example of semi-synthetic polymers, we have vulcanized rubber, we will talk about it later. We have also cellulose esters, including gun cotton and cellulose diacetate. The gun cotton is a nitrocellulose used to make explosives. In fact, this gun cellulose is obtained by dipping the cellulose in a mixture of nitric and sulfuric acids, and thus we will substitute the H of cellulose by nitric groups, and the aim to obtain a propellant for military weapons. Also, this gun cotton or this nitrocellulose could be obtained by dipping wood, which also cellulose, in nitric acid, forming by this way the nitrocellulose, also for weapons. After removing the remaining acids and drying the gun cotton completely, we can apply small flame, heat or spark, and the gun cotton will produce a flash flame of orange flame. Surely you have already seen such kind of orange flame and this special effects made by magicians. In fact, there's no magic here inside. It's just they have gun cotton, which is nitrocellulose, and they apply small flame or heat. And plus it's used as explosive under drying form. This same gun cotton under gel state with acetone, mixed with acetone or alcohol, is used for candles. In parallel to this nitrocellulose, we have the cellulose diacetate, which could be obtained by acetylation of cellulose with acetic anhydride in presence also of sulfuric acids. And it's used to make threads and materials like cinema films, negative films, and still using till now the cellulose diacetate for the same aim, and also to make glasses, etc., etc. Now the second classification of polymers is molecular classification. In fact, this category on itself is divided into 4 ways to name polymers. First one is the official one. Polymers could be named also according to the functional groups. We have abbreviations of polymers, slang, and trademark. First of all, the official naming of polymers is according to IUPAC, International Union of Pure and Applied Chemistry. This organization named polymer based on the monomer that was used to form this polymer. For example, we have here the ethylene. The obtained polymer is the polyethylene, which could be used for wires, films, cables, etc. We have also the caprolactane, giving the polycaprolactane. So the official naming of polymers is based on the name of the monomer repetitive unit. The second one is according to the main functional group in the repetitive unit of the polymer chain. For example, if I go back to the previous slide, here the caprolactane, the polymer obtained is named polycaprolactane. But also in this repetitive unit, we have the function amide, so we can name this polymer as polyamide. And plus here we have other examples, for example, of polyesters, which are used in clothing, wire, insulation, bottles, wood finish, etc. We have the polyethers, also used for clothes, etc. One important example of polyesters is the polyethylene terephthalate. This kind of polymer is obtained from terephthalic acid, and it's used in bottle applications. Exactly for water bottles. Okay. Another example also, we have the polyvinyl chloride. This polymer is used in many applications, and now PVC is the fashion in Lebanon. You have absolutely heard talking about polyvinyl chlorides. They are polymers. They are used, in fact, for windows and doors instead of aluminium, because this polymer is very efficient for isolation. This polymer is also used for boxes, kitchen boxes, bathroom boxes, to make sinks also, for wall coverings, for roofing, flooring, for pipes, water pipes, hot or drinking water, etc. Why this polyvinyl chloride is the fashion in Lebanon? In fact, this, but not just in Lebanon, it's everywhere. But in Lebanon, in fact, it's very expensive, this polymer. مع انه سعر الكيلو منه يعني ما بيتعدى $1, بس بلبنان it's very expensive because it's the fashion now. This polymer has something very specific. It does not fire easily. It's melting temperature between 100 degrees C and 260 degrees C, depending upon manufacturing. Means depending what kind of stabilizers are added to this polymer. This polymer has risk. It can emit hydrogen chloride fumes while burned, which is harmful, so we have to take care about this. As I said, this polymer does not fire quickly. Usually إذا رحنا شي محل بلبنان بدنا نشتري shoes or bags بيقلنا هيدا جلد طبيعي، so نحن أكيد الرفلكس تبعنا بدنا نقله بليز احرقه to see إذا هو طبيعي أم لأ. So أكيد هو راح يحرقه، ما راح تفرقه معه، حيدور له الفاير لأنه هو بالنهاية بوليفينيل كلورايد وما راح يولع. بس نحن نكون عم نشتري نايلون وهو منه جلد طبيعي، وبكون عم ببيعني إياه ب300,000 وهو أنجأ مكلف $. Okay, so take care of this point. Also, in the molecular classifications, the third way of naming polymer is using abbreviations. I already mentioned some in this presentation, so if you go back, you will see them. In fact, we can abbreviate polymers, particular polymers like polyvinyl chloride. I'm just talking about it. We can use the abbreviation PVC. We have the polystyrene as PS. We have also the polyethylene terephthalate, PET. If you turn the bottles, water bottles, for example, at home, you will find the sign PET or PETE, which means polyethylene terephthalate. Also, we can abbreviate polymers as family of polymers. We have, for example, unsaturated polyesters, we have polyurethane, we have polyreinforced fiberglass polymers. This family of polymers is very important one, very interesting one, very interesting type. They are used, for example, to make bridges in forests, in villages, in cities. etc. This material is well used because it's less heavy than steel material, do not rust, and because it has better mechanical properties. So we can find sometimes long bridges just made with polymer, which is polymer reinforced fiberglass. At the end, we have the slang and trade names. They are names in relation with the scientific name of polymers, but sometimes there's no relation with the scientific name, even with the structural information of the polymers. But these names, or these kinds of names, are used to facilitate the business communication of such polymers. For example, you have already heard absolutely with of Teflon. شركة تيفال يعني اللي بتصنعه، بس هو التeflon it's polytetrafluoroethylene polymer. It's abbreviated to Teflon and it's known under this name since long time and used under this name. We have another example, the Dacron. Dacron, it's a polyester polymer. It's used for synthetic polyester textile fiber. For example, إذا فكيتوا التكاية تبع الكنباية عماما بتلاقوا السفنجي covered بفوم أبيض، هو هيدا الداكرون. Okay. This is the second lecture. I will be back to you as soon as possible. Take much care of yourself and stay safe. Bye bye.